controller, and I think we're live. I think we are live. I think so. And we are live. Okay, cool. So, first of all, hi everyone. My name is Zach, and welcome to my learning sessions. This is where I live stream myself learning stuff and trying stuff with you guys, and I field as many questions and I learn as much as possible with everyone in person, and I also show some stuff I learned along the way. What are we gonna do today? We're gonna do some Zephyr today, some pure Zephyr. I think it's been a while since we've done that. What we're going to work on today is we're going to try and get the IMX219 camera, this one, working on this what is this thing called? IMX219 camera working on the Nucleo N6 570 basically development board. I think we've tried this a few times before on the stream, and we've had little success. Well, we got really close. We got to a point where we could sort of arbitrate the data coming out of the sensor into the machine, and we somehow could get the buffers into the machine, but we couldn't get them into the capture sample properly. So today we're going to combine quite a bit of work that has been done and see if we can manage to get it working, because quite a few we were working on quite a few PRs, and so far they've since been merged. So what we're going to do is try and work on the based on the merged PRs. The only thing that hasn't been merged so far right now is the IMX219 driver, and that's still in draft mode, and I know it's going to take a little bit of a while, but I know it works because I used that very same driver somewhere else, and it works pretty fine. Yeah, so cool. So first of all, let's get into it. I promise this is going to run on the Zephyr 4.3. So let's go pull Zephyr and see what we can do with that. Let's start by pulling Zephyr, the latest version of Zephyr. So git status. I believe, if I'm not wrong, I believe Zephyr 4.3 was released yesterday. So let's go and check. I believe Zephyr, the new Zephyr was released yesterday. It always goes to this pull request, man. Come on, forget this pull request. So I believe they cut and release. More stuff might have been merged, but a release was cut yesterday. Is my internet really that slow? Can we see releases maybe? Can we see releases? Releases. Yeah, 4.30 30 hours. So 30 hours last night, 4.30 was released. So let's pull that and see where we can go with that. So I'm gonna do clear git pull, and then let's pull all the new changes. So we do have the new tags and all of that. We're running on main. That's fine. And then I saw a message there. Git pull remote branch. Git branch. Git check out main. Okay, cool. And then let's do a git pull so that it can be pulled all the way forward. That's cool. Clear. And then I think I can do a git log, and we can see Lila Zoo, and that should be the latest thing on main. That should be the latest thing on main, Lila Zoo. Okay, cool. Fine, that's fine. Okay. So now what we need to do is we have everything locally. The next thing we need to do is probably do west update, because we need to pull all the other modules that have been changed, and I think that's going to be here. And then I'm going to do a west update, and then we can see. Let's get all of that stuff. Usually this doesn't, you do this at your own pleasure, but because we want to run everything new, and there might be some changes from ST that I want to pull in. I'm going to pull them now. So we have the latest changes we indeed have the latest changes now, and I think the first thing to do is probably to run. Let's build Blinky, run Blinky on this thing, and then see if we can do West. I think it was one of the most recent things I've done. So let's build Blinky, run Blinky, and make sure that Blinky just works on this board, and we're not going forward with something that doesn't really work. So that's cool. In the meanwhile, we can do questions, we can do greetings. Anyone? I'm looking forward to comments. Anyone? Greetings, questions. Say hi in the comments. Join the Discord in the description of the video if you wanna chat with us and you wanna hang out and do more stuff together, and you wanna learn together and such. Yeah. Sip of water. Build Blinky, make sure we're working off of a same thing, and then we go forward with the changes for that actual device. We actually probably need to build Blinky, check out the branch, cherry pick the IMX219 drive on top of it, and then we start doing stuff. Yeah, because we do need the IMX219 driver. Cool. And then I'm gonna put my device in bootloader mode now. That means changing the boot one header. That, and then you should get LED2 red if it's in bootloader mode. And then I'm going to go west flash. This should give us a good result. That's in. I don't see a thing there. And then if I just change back to normal running mode, we should have a Blinky. There you go. We have a Blinky. And I won't be showing the board much because I will be mostly working on attempting to get the thing working. And as you can see here, Zephyr, booting Zephyr builds 4.0, blah, 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 blah. So we're good. We know we're good. We know we're in same status. So now the next thing we need to do is come here and then say git status, git branch. So list all the branches. Git branch. Yeah, we're on main. So git checkout N6 IMX trial. Let's try that. Checkout -b so IMX trial. Cool. And then cool. So we are on the new branch. Git branch. New branch. Okay. And then what we need to do here is we need to merge the IMX219 drive on top of this, which is somewhere here. I think this is this is already in. This is already in, and the drivers. There's this draft driver here. So I need to merge that 88011. So I need that number, copy, and then git cool git. Wait. Is there one? What is it labeled? Git. What is this? St. Just let me see. Television IMXPR209, and the commits here. There's 6 commits, and what is the latest commit? I think I have it ready. Isn't it this one? IMX219. So I want to just see the commits and see the commit of the latest commit should be July 15. So 3065DA1. So okay, cool. So git check out PR IMX219. Just check it out. Git log. I think that's which one is this one? 36A PE91. Did I pull stuff on this? Did I change stuff on this? This is June 22 and this is June 22. So maybe some stuff was amended. I want to see. Anyway, the easier way is to just pull the gigs. Let's just pull the cable. Git pull checkout pull request locally. I should remember how to do this, or at least have it in my into this. I want this. Copy git checkout N6, yeah. Taking a bit of a while. Clear. Git branch. I'm gonna remove git branch. .d PR IMX219. I'm gonna remove that. I'm just gonna remove that, and then just to make sure I can actually. So and then I'm gonna do Control-V, and then instead of that, git fetch origin, I'm gonna say 880. What is that one? Is the one we want? 88011. 88011, and then here let's do PR IMX219. PR-IMX219. Okay, cool. There's that one. So git branch. Git check out PR-IMX219. Git full. It's the same thing. Anyways, it's fine. We have it. I think he did like a. This is the one, maybe. When was this? July, but it's probably like modded. Shields like 35. That's cool. That's fine. Now, check out. N6 IMX trial, and then let's plant the other stuff on top of that one. Clear. This is a lot of changes. Git merge PR IMX219. Please. Oh. Oh my word. No. Merge to. Yeah. So what is it that we want? What is it that we really want? What's the problem? So what is the problem? You want me to decide? Okay, I think I know what you want. So you want me to decide if I want what? One of them is ordered, and the other one isn't ordered. I think that's the difference, if I remember correctly. Because this one's still gonna be. Yeah, one of them is ordered and the other one isn't ordered. That's really the difference. Let's actually just go through this. It's fine. It's fine. This is why we're doing this. So let's go through. I think this one is keep sorted start, and then video email, video E, video E, video I, video I M O S there. Okay, cool. And then this is video, but it is the same things, but they're all in very different organizations. And then ST is down here, which is fine. So ST, which one is this? Which one is this? So this is STM to DCMI, and then is there DCMI on this list? There's no DCMI. This is shell. SHST. Yeah, that's fine. Okay, I understand. So cool. So it's just gonna be S3, and then I just want to remove all of this, I think, and then D, and then is there another marker? There's this marker over here, and I'm gonna do D, and then keep sorted stop ends there, and I'm gonna do a WQ, and then a WQ, and then a WQ, and then a WQ. And then what's this one here? This is my problem. I don't know. And then is this a sorted one as well? Yeah, this is also a sorted one. So let's actually just do the same thing. Accept the sorted changes. A cool video encoder. What do you want it to be as? So the drivers, OST, so that's not sorted. And then this one is sorted. The one here is sorted, isn't it? This is it's gonna be EGM. Okay, cool. And then cool, that's fine. So what we can't do, keep sorted end, keep sorted stop. Okay, cool. So what we can't do is we can't remove we can remove that, and then we can go back here, and then we can okay. Let's go remove all of this, because that's already been added all the way to the marker. Yeah, just go there. Maybe even to that, and then do a D, keep sorted start, and then this should just go like, it should just be good now. Keep sorted start, we go all the way down, yep, and then we can do a WQ there, and a WQ, and then a WQ, and then the next one is IMX219 input clock up. So this is the update overlay, and then what is the problem? Let's look at it. So IMX335 clock, I'm not using the 335, I'm not using, oh, this is just a test one, so this is tests, this is fine. Okay, so what is the problem here? There's an IMX219 over here. I'm not gonna really run tests, so I don't really know if I might want to run tests, but I'm not really keen on it. So okay, let's go and look. Let's go find the fast marker and see what the difference is. This is just okay. And then what does this one brings in that, and then here IMX219. So there's IMX219A here, and if you still go lower, if you go a little bit lower, so let's go back. If you go a little bit lower, then it's also double introduced at the bottom. So I see what happened. After this is the head. So what's before the head? 215. That's just that. But then IMX219 clock. That's okay, accepted. And then there's this guy, and then there's this guy, and then below that, that's fine. So perhaps let's just remove. It's basically asking me if I want to accept these new changes, because it used to be like here. This is my remote, so it used to be just straight here from OV9655. It went straight into the IMX one, but now we got a new, with the new 4.3 version, we got a new this is actually a good IR sensor. It's introduced now. I didn't know that was mad. So we got a new one that's in the middle of them, so we just have to accept it basically. This is an accepting change. We need to accept that one into the build. remove that as well. Remove that as well, and then that should be kosher. That should be kosher. Yeah, cute. Okay. Okay. Okay, cool. So that should be kosher. Git status. Wait. It should go like, I should be able to do something like allfix, use git commit to complete merge, git clean dash F probably, and git status, git commit. Can I just do that? And then it's gonna be, yeah, merge that to that, and then cool, yeah. Git status. Perfect. So, and then git log dash p maybe, dash p. So we see what's happening. Yeah, so we just merged that. Yeah, that's okay. That's a merge branch here and into this, which is just bringing in all the new stuff. Cool. I will depend on it working, and then actually the new thing we can do now is just do a test. We can do another build and test. Just do another blinky build, see if it actually works out, test it out, and then we can start actually modifying the capture sample for the IMX219 with the Nucleo N6. So let's do a build. Let's do a blinky build, see what happens, and then we can then start moving towards just to make sure that we merged everything properly. In the meanwhile, I'm gonna forward it. Does anyone have any questions so far? Does anyone have any questions so far? Any wondering? Any suggestions so far? Any questions? Anyone watching this for the first time today? I'd like to meet you. Just leave a comment. Anyone watching this that has watched this before? Which country are you watching this from? Okay, cool. So there's that. Let's set it into bootloader mode, and then I'm gonna do a west flash. Cool. It appears it flashed. I'm gonna set it into application mode, and then press the thing. Blink is working. Amazing. So now, what we want to do is we want to try. Not you, Bartholomew. You're not allowed to say which country you're watching from. So basically, as you can see, we can build it here. And then, okay, just to test that we brought in the N6 stuff and DCMIPP work properly, let's actually build the capture sample for the Nucleo N6. However, we need to build it for the software generator shield, and then video SW generator. Yeah, video SW generator shield, and then we can now start moving to add the actual camera. Just build up slowly so that we actually don't jump into something complicated and we don't know if it works. So as we do that, and then I'm going to add here a shield, and then this shield is going to be shield here is going to be video SW generator, and then it's going to be samples video samples driver video capture. Just a moment, I have an urgent call coming. I have to run for like 20 minutes. I need to go and fetch my new computer from the gate. Um, so some courier is delivering my computer, and I need to go and fetch it now. And this stream just started. Just a moment. Let me see if I can pause and see if maybe I can get some help in that way. I know the problem. So the first thing we need to do is probably set the RAM for the thing so that it actually works out. So my wife's not answering. So let's see. Oh, my new computer's here. So let's see here. Video. And then let's go into capture. And then I think the first thing we need to do is check what we need to do for our project conf here. And I think if I remember correctly, I have this changes stashed somewhere online. Let's go and look at the PR. Is it here? Something like here? I think so. So there's this branch I have, which is in the description. It's the last branch that we used to work on that had all the changes. So let me look at 23 files changed. I want to see update overlay is fine. I don't need update overlay yet. I need to do project.conf first. Actually, I can check it here. I have a stash. I have a local stash. And I think I can go something like stash. Yeah. We need this. We need we need these ones. We need these ones. Okay, cool. Copy. We need those ones, and then we need to put those ones in our project here. So N6 settings. And then I need to try and build it again. And then let's see if we can save the RAM. Okay, just a moment. I need to take a call. Amazing. We can stay. We can do all of it. The neighbors have collected my new computer that we are going to use to run Lattice Radiant. So we can actually build RTL for the... We can actually build RTL for the computer. So let's keep going. Let us keep going. Amazing. So yeah, let's build it. We just needed to secure some RAM so that it actually builds properly. And this should be good. And we should be able to do we should be able to run it with the video SW generator. This one is just to check that the DCMIPP stuff that we've merged in, or that has been merged in, is working properly, and that way we can kind of sort of separate everything that doesn't work and put it all by itself. This Nucleo N6 has the STM32 N6 chip, which is very powerful. It's kind of like the new media chip from STM32. And wherever you go on LinkedIn, most people are using this to do some AI, some like object detection, because I have the Nucleo, but then there's a Discovery kit which comes with the screen as well, and that has that's what most people are doing. Yeah, but let's actually check it out. Let's see if the RAM actually helps it right now. I hope this will actually get it working. So let's see if it does work with video SW generator. Otherwise, we have to like start debugging from afresh, which is not cool. Which is not cool. Amazing. Whew. I'm scared. So let's put it into bootloader mode, and then I'm gonna do a nice West flash there. Wait, into bootloader mode, West flash. Okay, cool. The West flash is coming. Application is running. Please hold on, and then I'm gonna go into application mode. And then I'm gonna go into pick a call here. Now what I'm gonna do is I'm gonna reboot the device, and there you go. So this is running. This is getting us frames. We're getting frames, and what we've proven here is that DCMIPP works. So DCMIPP is the new it's a new digital camera interface from ST. Documents. So let's see here. N6 documents. STM32 N6. Probably in here, and then is there a reference manual? Well, there's this, so that's cool. So let's see this. Yeah, so the CMIMPP is the new camera interface, digital camera interface on the new STM32 N6. So that actually works. So now what we can start doing is building up towards using the IMX219 camera that I have connected to the device. This actual camera here that is connected to the device. So let's actually start doing that. Since we've proven that with video this works and it works properly nice, so that's cool. So the first thing we need to do, the things that we've already done. So we've chosen a RAM buffer. We've chosen the size max of the buffers, and then we've chosen a video frame width and a video frame height, and then we've set the RGB format to RGBP, which is RGB 565. And then what we need to do is we have to set the other side of DCMIPP. So this took me a while to kind of figure out. So there's two sides to DCMI. And I'm going to try and find an image that shows it well to us. Yeah. So this is that's not too bad. So okay, cool. So let's actually look at this image. So there's a scene, and then there's a lens, and then there's a filter, and then there's an embedded image processor. Okay, cool. So there's two video settings. So we can set what happens before on this side of DCMIPP, which before it goes in through the digital camera interface, but basically between DCMIPP and the camera. And then we can also set what happens after. So we need to add settings that happen before so that we can consume the image format from the lens properly. That's what we need to do first of all. So let's actually do that. And this is the DCMIPP sensor pixel format, sensor width, sensor height. Those are the ones we need to set up. And yeah, so there's three actually. It's cool. There's three. And I think we can go back to our display over here, and then we go here, and then what we can do is, and then there's that. So this actually sets it up for us correctly, and then that's really what we want. The next thing we need to do is we need to set up our device overlay that will account for the IMX219, where it's connected and how it is connected. So cool. So let's do that. I'm gonna come here and I'm gonna make something called an app.overlay. So luckily we've tried this before. We have actually worked on this before. So there's no actual need for us to write this fresh. This all is this. And then by the way, this branch that I'm using is already linked in the description of the video, so you can get to this quite easily. But if you can't find it, please let me know and I can share the link again. And then you can also pause the video and go to this link. Well, no, actually not that link. So I'll share the branch. The branch is in the description. Cool. So let's open this file. I want to see this file. I want to view file, and I want to really copy this whole file. We will not be using the UVC port right now. We'll just be using the capture thing by itself, and then we can see what we can do from there. So I'll just copy this whole scale. And all this does is once I copy it, I can. Thank you for letting me know. Hey Moses, can you hear me? Can you hear me now? Hey Moses, Bartholomew, can you hear me now? I did pause audio at some point when I was taking a call. Can you hear me now? Please let me know. Could someone please let me know if you're getting audio out of this? Yeah. Yes, all good. Thank you. Yeah. Bartholomew, you don't have to be so mean. Bartholomew says, I hear you all the time. You don't have to be so mean. I'm not that boring. Okay, cool. So let's paste this in here. Allow. And I can run you through quickly what we're going to do. So here we're going to actually not use UVC because UVC for the N6 does not work yet, and we shall realize why. The first thing we're going to do is we're going to import the Raspberry Pi CSI connector. This connector, this CSI2 connector over here. I think we just did MIPP the other day, and we described what the CSI connector is. It's funny because all these streams are linking to each other. There's a stream. A couple of days ago, we looked at basic digital camera workings, and it explains what CSI is. So what we're going to do is we're going to import the device tree definition of the CSI interface, and then we're going to import the video interfaces so that we can actually use them. And then what we have in here is we're defining a clock, a 24 megahertz clock that we're going to use as a fixed clock input into the MIPP camera, and then we're going to choose the Zephyr, the capture port as the Zephyr camera. This also might be the wrong one. We just need to make sure that we're choosing the correct thing, because I think previously it was interface, and that was wrong. Yeah. So we also need to define which port we're going to be sourcing frames from, and then we are going to activate the CSI interface. So that's this little guy, and then we're going to define some pipelines, which is pipelines, ports, however way you want to call them. We're going to define some pipelines to be moving frames from the camera itself into the computer, and then from the computer into some buffer in memory, and then we can consume that. And then just below that, we define an I2C connection to the camera, and this is going to be our control plane. This is where we send our control messages from the computer into the camera. This is things such as telling it, go to this mode, use this Bayer format, start recording now, stop recording now, go to low power mode, go to high power mode, and whatever control interfaces you have. The IMX219 happens to actually be a very powerful camera. I wouldn't be surprised if it actually has an onboard image signal processing kit, and that would mean you can basically get it to bear and debear items for you and such. And then on the CSI connector, we are also sending power out to the IMX219 camera. So at this point, we're actually ready. We're quite close to where we were before. We're actually ready to almost try this. So let's try out a build and see what happens now. The previous time I tried this, I got an error. I got an error, and we had to like chase it through, and we'll try and figure out where it is right now. I don't think there's an error before, because most of this stuff is mainline Zephyr now, so it's been tested by someone else other than me. But sometimes I'm the one who's testing it for the first time. So cool. So let's save that, and then now we're going to build the video capture sample, but we're not going to use the shield. This shield I use is a video SW generator, and I'll just show you what a shield is. Let's actually look at what a shield is. Zephyr shields. Zephyr shields. Zephyr shields. So shields are sort of like, they come. It's a little board that has stuff on it. Okay. So you could have a little board that has Zephyr board. Actually, let's go Zephyr. It's easy to see from here. So shields are like a little component that has stuff that you can use in a certain way. Okay. So what I'm going to go here, and I'm going to turn off boards, and I'm going to choose some shield. So let's look at something that would be something that's easy to understand. So this is a memory shield. Okay, this adds what? This adds an EEPROM to your application, and then all you need to do is communicate to that EEPROM via iSpace. It just lets you it gives you some sort of functionality all packaged into one. I think shields in Zephyr are sort of like P modes in FPGAs, which is like some package functionality that you get and you can use in a certain way. And then this one brings in an LED matrix. This one brings in at least 3 MDL accelerometer and magnetometer, and so on and so forth. So the thing you want to see is this: there actually is software shields. Okay, there happens to be let's see, video SW. Let's see if we get something there. Yeah. So this is sort of a snippet. Oh, okay, cool. I misled you guys. So we're using a snippet. It basically makes up a fake video source, generating a test pattern and continuously for test purposes, and it is selected by the video camera thing. Okay. So what the previous way we ran this way, I'm gonna reset it. Can I reset? Okay. Let's go to the bottom. So I'm gonna do a reset. So this is running on software generated video. You see, video device, video SW generated. And what this is doing is basically it's running the video. It's running a fake video generator, and it's making sure that DCMIPP is working with this fake video generator, and it's doing well. So now we're actually going to try and use an actual video generator. Not an actual video generator, but an actual video source. Because now in our upload overlay is defined here, we actually define an actual camera, and we actually choose the camera. So that's actually cool. So let's build that, and we can take a couple of questions while that is building. Any questions while that is building now? Any questions, please? Okay. we did that. I didn't know we are the ones who made the, well, expected. Bartholomew, where are you seeing frame number? Oh, yes. Good frame. This one. This one. Okay, I'll show you where it comes from before we go on. While this is building. Okay, this should build now. While this is building, I'll show you where this comes from. So it comes from the application itself, Bartholomew. Frame number. How is it labeled? Got frame. So let's actually look at that. There you go. It comes from this. It comes from the application. So the application is just basically counting. There's a place where this frame plus plus. So the first frame 0, and then we just count them as we go along. Frame number comes from the actual application. Does that make sense, Bartholomew? This is coming from when we NQ and DQ frames from the image sense. Make sense? Line 2, overlay 2. What is happening? Thanks. Yeah, I see you understand, Bartholomew. Yeah. Let's look at here again. Is this, do you want it to be like that? Is that what you want? Yeah, I think that's what Zephyr wanted. Any more questions, Zephyr? Any more questions? You can ask as basic of a question as you want. Like, you don't have to like. Okay, I think we're going into something different. Something change in Zephyr, and we're gonna actually have to find out which one it is. CSI capture port. CSI capture port. I think so. I think I know where this change comes from. First of all, let's actually just look at this, and I want to view file. So something changed in Zephyr. Definitely something changed in Zephyr. So we're going to have to go find out what changed in Zephyr. So is there a CSI capture port? There is none. And where we're going to find this, we're going to have to go to the. Okay, Moses, I'm gonna answer you just now. Moses is asking about the overlay. I'm gonna answer you just now. So let me find the file that we need to look at, and then I'm going to answer you, Moses. Zephyr boards TM36. Bartholomew, answer that question, and then I'll answer while I find this board. Nucleo N6. Nucleo N6. Nucleo N6. Nucleo N6. Or maybe STM32 N6. HDN, yeah, STM32 N65. 7DK, but that's not really the one we want. This is the DK, so this is not the one we want. Okay, actually I can go here, Nucleo N6, and I can do browse board sources. And then let's see, browse board sources. So in here, where's this ST Nucleo N6? I missed it. Okay, cool. So, thank you, Bartholomew. Moses, you're asking, what is the use of the dot overlay file? And I've been seeing it a lot, even in a Pi. Even in Pi. So, dot overlay file is let's look at here. Zephyr overlays. So this is how you, like Bartholomew answers. Bartholomew's answer is very correct. This is additional configuration for the project. In case you get, so when you have a board, like a blank board like this, that's an STM32F4, and you want to tell Zephyr that on these pins I have added a camera on these pins. You use an overlay board to tell Zephyr that you've added a camera to this such and such pins. You can also use an overlay to add more than that, but the primary reason is like Bartholomew says. It's additional configuration for the project, and this is applied to the current device tree source file. Yeah, thank you, Bartholomew. It's amazing having you around, man. Amazing having you around. Cool. So let's actually look at what changed. Let's look at what changed here. There's going to be something that change in here that is going to be the one. Okay, cool. So not that. So not that. So this is just that, and then we just want to find out where that camera interface is defined. Flash input pin control. That's okay. That's fine. CSI. Yeah. So let's find CSI port C, CSI capture port, CSI ports, CSI interface, and DCMIPP. No. Okay. So it's probably here. It's probably in here. There used to be a CSI capture port. I remember. And then there's this one, STM32 N6 DTSI, this one. So let's actually go and find this guy. So I want to go find that one. And I know that one's it's probably in ARM, in binding and such. Yeah. Thank you, Bartholomew. Let's go find this capture port and where it changed. So this is probably going to be in Zephyr DTS, and then I forget. I usually have to go into DTS and then I remember where it is. So it's going to be DTS and then probably something like DTS and then ARM, if I remember correctly, and then I think we want to find which one is it that we want to find. STM32 N6. STM N6. Okay, so DTS into ARM, and then we want to go to ST, and then from ST we want to go into, they say N6. N6. Come on, I'm missing it. It's right in front of my eyes. Yeah, N6. And then which one is it? We want to go N6 570X0. Cool. Sorry, that's the wrong direction. This one, DTSI. Cool. And then this one's going to have some definitions here. This is C. And then what is this supporting? And so let's go backwards. Open that one. It's this one. Let's see that one. Okay, this one, and this one's pulling out the one before it. And then we go in here, and hopefully this is a giant one. Yes, perfect. I hope this is not pulling anything. Yeah. So, and then you do Control F CSI. CSI. the blame. View blame. Does this change? Something that changed really recently. I want to see the blame for the CSI. Oh wait, 5 months ago. Am I allowed to just go and ask Elaine what changed? Just ask. So it looks like CSI capture port. Maybe we go back and we pull a different version of Zephyr and then we just search in it. So let's go this and let's go actually. How do we find a different version of Zephyr? How do we pull a different commit of Zephyr? 4.2. How do we go to 4.2? Yeah, so there's going to be a commit they're going to give us 4.3. No, I want 4.2 completely. 4.2. I'd like to go here, and then I would like to go. Once I'm in here, what I would like to do is search Zephyr CSI capture port. I think we found it. Oh my god. CSI capture. No, I can't do that. I can't do that. So Nuke again. Bartholomew. Again. Shouldn't be that. Should be this. Shouldn't be that. Should be this. And I think it's already that, so. Undefined node label CSI capture port. What am I doing wrong? Undefined load label CSI capture port. It was, and it worked. I remember very well. It worked. It's like some alias has been removed, and I remember it was a label or something. It was a label. It was some sort of label. Yeah, here in port one. Where's this? In port one. In port one CSI interface. So this is port one. Is there like a missing? No, you see, it's defined so deep. But okay, we know it's port one. It's this one. It's quite deep. Um, it's port one of where DCMIPP is defined. Control F DCMI. Yeah, see here. Okay, so can we go back? Yeah, this is on main. This is on main. So what if we do CSI capture port here? So let's first CSI interface. CSI interface. No. No. Yeah. I swear this has changed. I swear this has changed. This has changed. This has changed. This has changed for sure. Get blamed for just this line and show me exactly this line right now. See? Told you. See, I told you. See, I told you. Okay, let's go back and find that. Let's go back and find this commit. Let's go find this commit by Joshua. No. Hmm. Hmm. Okay, so which file is this we're looking at? CSI interface. Um, what comment is this? This is a comment we're looking at. Nothing was removed. No. This is Bartholomew's fault. Every time Bartholomew is here, we have to discover an error in Zephyr and then we have to go fix it. CSI capture port. CSI capture port. And Bartholomew thinks we need to do dash dash dash. The dashes are supposed to be here, Bartholomew. Here. That's just side interface. Capture port. It just disappeared. Oh, look at it, look at it, look at it, look at it. Let's look at this. This is a dump pipe. We don't want to use the dump pipe. We want to use this one, but this is just an endpoint. This label, this is not labeled at all. I am so confused. I am so confused. We basically have become Fee might know this. I don't know. Fee seems to be the one changing this. It seems. So what's the new label then? What's the new label? What's the new label? What's the new label? And how do I make it work now? Because this doesn't work now. How do I choose a camera? I can't choose DCMIPP as a camera, can I? Let's go and look at what the DK thing is doing. DK might actually be a much easier place to look. Let's go and look at what the DK is doing, okay? I just need to know where my port went. And if you tell me where my port went, I can just go follow it, but I don't know where my port went. Let's go look at the DK, because the DK should have a camera selected already, and then we can look. N6 DK, no? STM32. STM32 N6 DK. Because this one comes with a camera already. So maybe the DTS for this already just gives us a camera, so we can just go for it. Okay, cool. So that's fine. Let's look at probably the common DTSI. So this should have a camera. Display yes, touch yes, code partition yes, but no, it doesn't have a camera. It doesn't have a camera. Okay. Okay. Size, let's see, that's fine. Exit PI, that's fine. This is all okay. This is all good. Interface and DCMIPP, that's okay. But it doesn't. Let's just give it a moment. Does anyone have any ideas of how to fix this? Oh, we're kind of finding it? We found it. We found it. There you go. So capture port goes back main. Let's main. Okay, cool. So that's not too bad. That's not too bad. That's not too bad. Cool. Oh, we've gone past building. We're building now. We actually built for it. Okay. Any questions so far? Bye. Thank you so much for showing up. I'm gonna finish building this and then I'll see. I also need to go soon, but I have to kind of finish something. Thank you so much for coming by, Bartholomew. We're almost there. Aha. Aha. Why would you stay? No, we're gonna Bartholomew. We've actually found the next thing. So I think we need to fix this. I think I need to apply this patch into the IMX driver, IMX219 driver. I'm gonna conclude just now, Bartholomew. Let's just put some questions up and then we actually have something to do, maybe even over the weekend, yeah. Maybe some very little changes to do over the weekend. Okay, cool. So we've gotten actually pretty far along this time around. This is pretty good because we've managed to build everything and we've managed to find all the changes. And we basically can all the way build up to what this was which stage of the build, 159 of the build. It looks like the IMX driver has fallen behind the new video interfaces because video is really changing in Zephyr. We're trying to the video developers are trying to really keep it up to date such that we can actually use pipelines, media pipelines, and we can actually do things like GStreamer sourcing and syncing, all of that good stuff. And previously we got quite close, but we were still having problems with the DCMIPP side of things. I think now we've gotten so far that DCMIPP is kind of sort of working because we've tested it with SW video generator and we've now discovered that the IMX219 PR has fallen behind. I think I'm going to get what I'm going to get is some patches from Joshua and I'm going to apply them to the 219. And I'm really hopeful that this is something that is very close to working now because this is now this is now a driver that's feeling like it's very solid, and it's having people from NXP, ST, and everyone else, and Tiny Vision work on it. It's getting really solid now. So let's get. I posed a question on Zephyr. There's a Zephyr thread. There's a few months old Zephyr thread for this, and there's a if you go to the video, if you go to Zephyr video, there's a thread, Nucleo N6, DCMIPP, and IMX219, and that should, you'll find a 2-month-old discussion where we're trying to fix this, and everyone is participating. It's going really well. That was a lot of nice progress today, I think, because I feel like it's very close. Everything is just falling into place, and we're almost close to running this. Thank you so much for all of those who came. Thank you, Moses. Thank you, Bartholomew. Thank you for all the questions. Really glad to have everyone here. And anyone else who didn't get a chance to ask a question, there's a Discord community. Join Zephyr, start developing with all of us. And I'm really happy to develop with all of you. As always, my name is Zach. Remember to be daring. See you guys another day. Thank you so much. Cheers. Bye.